Hi, I'm Shannon Henry, an applications engineer here at EMI Design Automation. Today we are discussing common uses for copper planes and pores in your design: power distribution, electromagnetic interference reduction, EMI shielding, ESD guard bands, and heat sinks. The most common use is utilizing a copper plane for power distribution. A power plane is a most effective way to distribute the necessary power to multiple devices. While the thickness can vary based on the design requirements, pins can be connected to the plane through vias. Another use of a copper plane is to reduce electromagnetic interference, or EMI. One of the best ways to reduce EMI in a board is to place a ground plane underneath the traces. This is because current always seeks to close its circuit by returning to ground. Placing a ground plane directly below the traces provides the shortest path. Another way to reduce interference is with high-frequency bypassing. This is completed by placing power and ground planes closely together in the stack-up, only separated by a thin layer of dielectric material. This turns the planes into an excellent high-frequency capacitor. Calculate the corresponding capacitance using this equation, where A is the area of the board and D is the distance between the planes. Copper planes can also be used for EMI shielding and ESD guard bands. When placed around a sensitive trace or component, a layer of copper attached to ground can provide a shield. Multiple ground planes can be stitched together to form a type of Faraday cage to keep EMI in or out. When the stitching is placed at the edge of a board, it can have a similar effect on electrostatic energy. This is an inexpensive solution to keep electrostatic discharge from reaching critical circuits. If you have high heat components in your design, planes can be used as a heat sink. If the body of a specific component is connected to an outer layer of copper plane, the plane will naturally draw the heat away from the component. As the heat moves through the copper plane, it will dissipate. If more dissipation is necessary, multiple planes can be stitched together using vias. Copper planes and pores can have various effects in your design. If this feature is used correctly, it can help simplify routing, reduce EMI, or dissipate heat. Remember, if you have any other topics you would like us to discuss, add them to the comments below. In the meantime, be on the lookout for more Whiteboard Wednesday sessions from the PCB design experts here at EMI Design Automation.